Welcome. Right now, let's talk about homeostasis. Homeostasis. Today, David7 Sciences Theater at gmail.com. Don't forget to subscribe for more and better videos. You can contact us, consult. All right. So, yeah, that is it. David7 Science Theater. And don't forget to like our videos, subscribe for more and better videos, and please share to other people to also enjoy the science. Share the channel, share the videos. They are good to watch. You will learn a lot through our videos. All right, so homeostasis, this word was discovered or was invented by W.B. Cannon a long time ago, but still in the 19s. But what he discovered is that there is a mechanism by which constants of the internal environment is maintained and assured. And this very mechanism is what he called homeostasis. And for this purpose, living membranes with varying permeabilities such as vesicular endothelium and cell membrane, they play an important role in this process, in this mechanism of homeostasis. Okay, and the factors involved are very many, as I'm gonna mention many of them. We can start by one, transport of the extracellular fluid. That is also important in homeostasis. Another factor, there should be maintenance of pH of the extracellular fluid. This is what they label acid-base balance. Then other factors, we can have regulation of temperature by the body. We call regulation about the normal temperature, which is favorable for the enzyme, which is optimum temperature for enzyme activity to be at the peak. Okay. Then we have maintenance of water and electrolyte balance. This factor is also involved. Another factor is supply of nutrients, oxygen, enzymes, and hormones. All these must be supplied in this process of homeostasis. Then there should be removal of metabolic and other waste products. All these are happening to maintain a constant environment, okay, within the body. Then we have reproduction. This is also part of homeostasis. So we're going to talk more about homeostasis in this very video. I'm going to describe more about it. I'm going to give you advantages. So it is going to be not too long, but it will be full of learning a lot. Let's continue. So what is the mode of action of this homeostatic control system? It has a mode of action or a mode of operation, and the mode of operation of all the systems which are involved in the homeostasis is through feedback mechanism and adaptive control system. So as we go along, I'm going to describe more about feedback mechanism, and I'm going to talk more about adaptive control system. And if you look at this, the feedback mechanism is of two types. There's negative feedback mechanism, and there's also a positive feedback mechanism. All right, so negative feedback mechanism, I start with that. Okay, with the the negative feedback mechanism. And in this mechanism, most control systems of the body act by this. That is, in general, if the activity of a particular system is increased or decreased, a control system initiates a negative feedback, which will consist of a series of changes that returns the activity towards the normal. So this is all about how the negative feedback mechanism operates. For it, it will return the activity towards the normal. And the examples of negative feedback mechanisms I can give here, we have one. There are several mechanisms. Almost the entire body uses that. So when the blood pressure suddenly rises or lowers, it initiates a series of reactions that tries to bring the blood pressure to normal levels. Okay. Another one is like when thyroxine secretion is more, it inhibits the secretion of thyroid stimulating hormone from the adenohypophysis, so that thyroxine is not secreted from the thyroid gland. When the thyroxine is high, it inhibits its own secretion by acting on the pituitary gland. So that is it. Let's continue. Now let's tune to the positive feedback mechanism. Because we said we have positive and negative feedback mechanisms. So the positive feedback mechanism is better known as vicious cycle. And in this cycle, usually it is harmful, and in some instances even death can occur due to positive feedback. Okay? So for example, when a person has suddenly bled 2 liters of blood, a vicious cycle of progressively weakening of the heart is set, which ultimately causes death. You should take care of this. Sudden blood loss, 2 liters, a vicious cycle of progressively weakening the heart is set such that this might cause death, okay? And how is it bad? For example, if you look at this, just as I've said, it will cause death. When there's bleeding of 2 liters of blood, the blood pressure will decrease, and the flow of blood to heart muscles will also decrease. Recall we have coronary blood vessels taking blood to the heart. So when the blood pressure is low, even flow of blood to the heart will be decreased, and the heart will be weakened in contraction, so there will be decreased pumping power of the heart, and this decreased pumping power further reduces the blood pressure. So you can notice that in this positive feedback mechanism, there is no bringing back the cycle to a normal level, but otherwise they continue diverting from the normality. They continue diverting from what is normal to the body. So you see, they are further decreasing the power of contraction of the heart, which will ultimately cause a death. So this is a flow chart. Let's continue. Sometimes we have mild positive feedback, and in mild positive, a mild degree of feedback can be overcome by the negative feedback control mechanisms of the body, so that this vicious cycle fails to develop. Okay, so when positive feedback is mild, the negative feedback can overcome it, so that there is no death which occurs in the case of the recent example, the previous example. So, for example, when a patient has just bled just 1 liter, if you try to compare this to the previous example, instead of the 2 liters, the negative feedback mechanisms of controlling the blood pressure may overcome the positive feedback, and the blood pressure will return to the normal. The normal blood pressure will be restored. And how is it useful? In such times, like positive feedback can be of a very great importance. For example, we have a couple of situations where positive feedback has benefited human beings. For example, one, when there is a formation of the clot followed by rupture of the vessels, okay, sorry, look at this. Clot formation followed by rupture of vessels is accelerated by the vicious cycle of thrombin formation, and this will stop bleeding. Thrombin is important in formation of clot. So when there is rupture of a blood vessel, clot formation is very important to stop the bleeding. But a positive feedback comes in that there will be continuous formation of thrombin to curb the blood. Clot formation, we are done with that. The second useful positive feedback mechanism is here. When there is labor, childbirth during labor is facilitated by progressively increasing uterine contractions due to positive feedback from stretching of the cervix by the head of the baby. So as the baby is getting out of the body of the out of the womb of the woman, the cervix is stretched, and that stretching initiates a positive feedback mechanism which further increases contraction of the uterus so that the baby will be ejected out of the body. The third positive feedback mechanism is generating of nerve signals by the vicious cycle of progressive leakage of sodium ions from the channels set up following stimulation of membrane of nerve fiber. And this is due to also a positive feedback, because As sodium enters when they are generating a nerve impulse, there is a positive feedback which ensures that more sodium still continues to enter, such that the action potential will be evoked after, generating a graded potential which will rise to beyond the threshold. Okay, membrane potential will have to be raised to a threshold level to evoke an action potential which can be propagated. So this will require a positive feedback mechanism to ensure that more sodium is entering the axon. Okay, let's continue. Now we've tuned to the adaptive control system. The adaptive control system just refers to a delayed type of negative feedback mechanism. Delayed type, as you can say. And this is usually seen in the nervous system. For example, when some movements of the body occur very rapidly, there is not enough time for the nerve signals to travel from the peripheral parts of the body all the way to the brain, and then back to the periphery again in time to control the movements. So what does the body do? Have you noticed this? And when some movements are occurring very rapidly, there is not enough time for nerve signals to travel from periphery to the CNS and then back to the periphery again in time to control these movements. So what the body does under such circumstances, the brain uses a principle which we call feed-forward control to cause the required muscle contraction, which retrospectively is conveyed to the brain by the sensory nerve signals from the moving part. Okay, so that's how the body does. That is the adaptive control system. To talk more about it, if the movement performed is found incorrect, then the brain corrects the feed-forward signals that it sends to the muscle the next time the movement will be required. Okay, and such a correction made by successive retrospective feedback mechanisms is called the adaptive control. Right, this you know it. Feed forward. We see it in the brain, in the CNS. Okay, and to add on, don't forget to like our videos. Please subscribe for more and better videos, and share to other students to also enjoy our videos. They are always good videos, that trust me. Okay, Homeostasis in the coming videos. Okay, just as you can see that we had a lot. We talked about the temperature. Okay, we talked about the temperature. We talked about a lot. So these factors, we shall bring more videos which will be talking about how ECF is transported, the maintenance of pH, that is acid base balance, for example, regulation of temperature. Our videos will be having those different videos, but this is an outline of what is homeostasis, what does it do, what is involved, maintenance of water and electrolyte balance, supply of nutrients, oxygen, enzymes, and hormones. All this we shall show in the next video. A removal of metabolic and other waste products, and last reproduction. So all our videos are going to be having this. Just trust me, watch, don't forget to subscribe.